Lukitas, live here at the Bureau of Forensic Toxicology, but this isn't just what you see on CSI. Coming up, I'll show you how some of these tools can help police solve some pretty high-profile murder cases.
These answers are uncovered.
That's right, Andrew Shera. I'm live here at the Utah Department of Health's Toxicology Lab. Now, this is where evidence is sent after it's collected, and it helps police determine, what led up to the cause of death in some of these high-profile murder cases. Now, I'm joined here with Nia Nguyen. He's a forensic toxicologist here at the lab. Now, I know we can't talk about any cases specifically, but how do you guys use some of this really cool technology to help them solve these cases?
Oh, well, with all the samples we have, we receive samples from medical examiners and the law enforcement community. We use all this new technology here to determine what drugs are in the body at the time.
Now, show us what we have right here right now.
This is our GCMS instrument, and this we use to run prescription drug screens. So once it screens for a prescription drug, then it goes to a confirmation. And so for any result we put out, it has to have a positive result on the screen and a confirmation, and we do that for the drugs of abuse. Morphine, cocaine, THC, and meth, and also about 27 prescription drugs.
So what is it doing right now?
Each of these valves is a subject, and it's injecting in this instrument, and it goes through a column, and when it gets to the column, we can identify it to our controls and our calibrators, and when we compare them, we can identify what drug it is.
Very, very interesting. And so coming up next, you guys have to stick with us. We have some really cool instruments to show you coming up next, and how many cases they solve every year. It's incredible. So stay with us. Andrew, Shera, back to you.
Caitlin, thank you. Yeah, with a lot of cases.
Well, you might have seen some of these toxicology labs on shows such as CSI, but there's a lot more technology and science to it than you might think. I'm Caitlin Lukitas, and coming up, I'll show you how labs such as this one help police crack some pretty tough cases.
Police wouldn't be able to get answers to cases like this without the help of a very special, crucial team here in Utah. Caitlin.
That's right, Andrew, Lori. That team are the folks who work right here at the Utah Department of Health's Toxicology Lab, and they do some pretty cool things here, actually. In fact, it's kind of neat because we're standing here right where actual samples are being tested, and police really rely on this technology here in order to get to the bottom of some pretty tough-to-crack cases. Now, I'm standing here with Nia Nguyen. He is a forensic toxicologist here at the lab. Now, show us, these vials are so small. How do you get from that to this from that?
So what we receive from the law enforcement agency is a test tube of this blood right here, and it's about 10 mils what we normally get. And we have to have a recipe, an extraction for all of these. Now, each drug could be, like, let's say you want lemon bars or a chocolate chip cookie. You have to cook it differently. So when you cook it, you get to a nice thing like this, such a small volume, and it's a nice clean, and the drug's in there, and you have to load on the instruments, and each instrument will test for a different drug.
Very fascinating, and this is also extremely fascinating. There's only 7 of you guys here in the entire state that handle about 8,500 cases every single year, and they do it in, a 14-day turnaround?
Yes, average is 14 days, and there's 50,000 actual tests that are done on these 8,500 cases.
Fascinating. Thank you so much. Andrew, Shera, back to you.
All right, thank you, Caitlin. Very interesting. Morning, in the case of a Colorado teen killed at a West Valley City hotel, the Mesa County Coroner's Office says Kelly Myers died of a mixed drug intoxication.
And police wouldn't know that without the help of the state's toxicology lab, solving cases just like this. News specialist Caitlin Lukitas live this morning to give us an inside look behind how these answers are uncovered. Good morning, Caitlin.
Good morning, Andrew Shera. This is where the magic happens. Right now, I'm standing in the Utah Department of Health's toxicology lab. It's so cool because this is actually where all the samples are collected, and this is where they go to be tested to help police find out just what happened and the cause behind some of these victims' causes of deaths and really hard to crack cases. Now, I'm standing here with Nia Nguyen. Nia is a forensic toxicologist here at the lab. This is just so cool, and you're only one of 7 in the entire state who does this. 8,500 cases within 14 days. That's a 14-day turnaround. So that's why you rely on new technology such as this. Can you kind of show us what this is?
Yes. So this right here is our new tandem quad. We use a combined method on this one. Before, we had to do a separate test for morphine, cocaine, THC, and meth. And now with this instrument, we can combine THC, meth, and cocaine in one test. And that saves us so much more time. That really helps with our turnaround time.
So show us how this works.
Okay. So we do the extraction, and the whole blood in a blood tube that we receive from the medical examiners or law enforcement, we clean it up and extract it, and we get a clear sample like this of a small, very little fluid. And this is what the instrument will inject.
Very interesting. Thank you so much. Now, coming up next, stick with us because we're going to show you some really cool equipment and some really cool things, so you don't want to miss that. Andrew, Shara, back to you.
All right, Caitlin Lukitas live up at the University of Utah talking about what this means to solve these cases. Really interesting stuff, Caitlin. Thanks.
Good morning. I'm Caitlin Lukitas live here at the Bureau of Toxicology. Now I'm all suited up and ready to go to show you some pretty cool experiments. Coming up, I'll show you some really awesome equipment and how it helps police crack some pretty tough cases.
All right, Caitlin, thanks. We have learned a Colorado teen killed at a West Valley City hotel died of a mixed drug intoxication. Kelly Meyer's body was found in a suitcase near the Utah-Colorado border, but investigators say she was killed in West Valley.
News specialist Caitlin Lukitas joins us live now with more on how police wouldn't be able to get these answers without the help of a very crucial team here in Utah.
That's right, Andrew, Shara, and that team are the folks who work right here at the Utah Department of Health's Toxicology Lab, and some pretty cool things happen here in this lab. In this lab, right now, they're actually testing for a lot of different drugs and alcohols to help police solve some pretty tough, hard-to-crack cases that they come across every single day. Now, I'm all suited up. I got my lab coat on and my safety goggles, and I'm joined here with Nia Nguyen. Nia is a forensic toxicologist here at this lab. We're going to start testing for alcohol right now. Is that right?
Yes, this is our most common test. We do about 120 of these a week, and this one, it's head space gas chromatography. This is basically an anonymous sample. We just do every sample by number, and it goes on this instrument, and it's run 3 times a week. And like I said, our most common cases are DUIs here.
Wow, and it sounds so official right now, but what's the name you like to use?
I call it all sweet science magic, just the layman's terms.
Sweet science magic, fantastic. And there's only 7 of you guys, right? And working with 8,500 cases. Why is there such a quick turnaround?
Oh, we've implemented new processes where we can screen it on a certain day and then the next day do the confirmation. Also, we have new technology that enables us to do testing faster.
Fantastic. Well, we're going to start working on some sweet science magic right now. In the meantime, I'm going to send it back to you, Andrew, Shara.
Wow, very interesting to see how those cases move forward with that technology. Thanks, Caitlin.